In this chapter, we will talk about programmer-defined functions. Up until this point, you have been using functions already predefined by the C++ language, as in the example of calling on POW when you ask for it to find, a base value raised to an exponent. So we're going to talk about how to define and call functions designed by the programmer. So a function is a collection of statements that perform a specific task, like me calling out just to specifically get the base raised to a certain power. And so in programming, in more modern programming, we break our functions down to be as task specific as possible. That way I can always call in. Why rewrite the algorithm to take a base and raise it to a power when I can incorporate it into the language and then call on it? And so we can actually do that with programmer defined functions as well. A function call is a statement that causes a function to execute, and then the function definition are the statements that make up the function. So a function like POW, and then passing it two parameters, and of course I can use variables to do that. Somewhere out in the language there is a function that has a body to it that is called upon that holds the algorithm of raising 2 to the 4th power. The function call, so this would be an example of a function call where I am asking for x to be set equal to the POW. That is a function call. This would also be a function call when I set it inside of a cout statement, because we know that the POW returns a value, and so I need to capture it somewhere, whether it's in a variable or into a cout statement. Sometimes that doesn't happen, but we're going to talk really about how do I make my own function definition. So function definition has to have a couple criteria first. It needs to have a return type. What is the data type that the function returns when it's done executing? In the case of the POW, it returns a double. So I need to assign a variable of double type, or we're just going to display a double version of 2 raised to the 4th power. So it needs to have a return type. It needs to have a name. POW is the name of the function, and we will define names for our functions using the same naming rules that we use for a regular variable. Take notice the POW is all lowercase. We use lowercase on our general variables. We might use camelback lettering, for a variable that, let's say I call it interest, let me call it add interest or additional interest, where I use that camelback lettering. We use that same sort of naming scheme when defining our functions. What about the parameter list? The POW took 2 parameters in specific order, took the base first, and then it took the exponent. So we need to define in what order is it going to accept the parameters for the sake of executing the function properly in the way we want to define it. And then the body, what does it look like? We don't see the body of the POW. It is in the library for the language. We don't see it, so we're not quite sure how it's defined, but we do know that it executes some lines of code that's going to return 2 raised to the 4th power. And so we're going to look at how do we define that ourselves as a programmer, noting that they are encased in curly braces. The number one function that you already execute right now is int main. He is a function. He is the main function from which all executions are derived from. He has a return type. That's what that int was all about. Okay, he has a name. Now, main is specific. I can't just call any function main. It has to be specific, but he doesn't have a parameter list like the POW had. All right. And in this case, he's performing a set of tasks. Because he has a return type, we use the keyword return. So in the POW function, it's going to have a parameter list indicating what kind of parameters it accepts. In this case, it accepts some doubles, and it's returning a double, and it has a body which has the algorithm from raising 2 to the 4th power, and it is going to return some value. So there's probably a local variable in there set equal to 2 raised to the 4th power, and that's going to be returned using the return statement back to where it's called. This is what we call the function header. This would be the example of a function header. So if I look at what my program now might look like, so in my file, this was going to be all of my main function, and then with subsequent functions to follow. We'll talk about layout in a moment because I actually can reverse the order. It just changes how I program it. But here we see int main, and in there might be a call to function 2. And so when the call to function 2 occurs, it changes and sends control into the function. It executes the body of function 2 and returns control back to where it was called from. And maybe it's a call to function 4. They don't have to be in order. Call out the function 4, it goes out, performs the body of function 4, and returns control, and so on. Now, these are void. We'll talk about why they're void and that they're a little bit different. But again, the idea that we are taking what might have been, a chunk of statements that are performing the same task that's in function 2. But if I'm going to repeat these things over and over, it makes more sense to make a function out of them and then calling on that function repeatedly than it would be for me to re-execute those same lines over and over again. Kind of like you making that call out to the POW rather than including that algorithm each time you want to execute 2 raised to the 4th power. So the function has a return type. It could be any primitive data type, so it can return an int, a double, a boolean, a string, a char. So it may, though, at times not return anything. All it does is perform something, but doesn't actually need to return a value, and therefore we would use the keyword void. So you can see here that this one isn't going to return a value. All it's going to do is perform a task. In this case, all it's going to do is print hello world to the output, to the console. So there's no need for the return statement. Only when I have a return type indicated of like an int, a char, a boolean, a string, a double, and so on, when I use the designation of a void, it doesn't actually return anything. Now, I can only return one value, though. I can only ever return one value from a function. If I need to return multiple values, we'll talk about what that might look like in a little bit. So to call a function, we'll use the function name followed by parentheses. So this one is a void type, so nothing can capture it. If it has a return type, we, as I noted before, would set it equal to a variable, or I could place it in a cout statement, something that was going to capture the return type. Otherwise, it gets left out in the system as garbage. So this one is not going to return anything, but this is a function call where I'm going to call on it to display the message, and it will display hello world to the screen. So we'll execute the body of the loop or the body of the function and then just return callback. So after the function terminates, execution will resume where it left off in the main function. So here's an example of how that might work. So here we have a definition. Here is void display inside. This is the file itself. We have defined display message to print hello from function display message. Here's my main function here, again with the return type of an int. This one has no return type, so there's no return statement. So it says cout hello from main. Then it has a call to display message. So control of the program is going to be turned over to the function display message, which says to display hello from the function display message. When it's done doing that, it's going to return control where it left off, which is going to be this execution here, which is a cout statement stating back in function main again. Then it returns 0 because that's related to the idea of the int here. So we can see program output. Hello from main was that first definition, then the call to the function, hello from main function display message, and then the call back in main function again when it returned control from the function back to the main function. This is one way to lay out the program. They defined the function first, and then the body, the main function appears afterwards. So program layout, one of them was what I just defined previously, where we defined the function first and then the main function. If I don't do that, the compiler in C++ can't identify the function display message when it's trying to be called from int main. So that was, again, this example here where I predefine the function and then I have int main. This is one valid way to do that. And this is a programming style. There's another way to do this. So in this example, here we can see we have prototypes. They're defining the fact that I'm going to have a function called first and second, but the programmer has decided they like to have their main function first and then follows the body of the first function and the second function. I personally program in this style. For one reason is that the prototype helps me debug my program to some degree. If you prefer this order, that is fine, where the main function is at the bottom of your function list, or you may program it with the prototypes, but you have to define them, and that's what the prototypes are doing. They're defining what it is the function's going to do, okay, or that the function exists, so that in int main we know that at some point it's going to be called. That's like defining x to be an integer at the top of the program before I actually use it in the program. And that's this type of layout. And we'll look at the different behaviors in the lab. So function prototypes are a way to notify the compiler that a function exists and what that definition might look like to some basic level without actually knowing how the function works. We place a function definition before the calling function's definition, and really all it is a copy and paste of the header, and all I did was slap a semicolon at the end of it. Okay, it's without also defining the body right away. All it is indicating that there is going to be a function call to display message. It is a copy of the function header with a semicolon at the end of it. So we can see that here. It looks exactly like the function header. The only difference is it's got a semicolon at the end, but it's very similar to defining it before we actually use it.